Coefficient of determination and standard error of the estimate. Applications in agriculture business. Terminology. Coefficient of determination, R squared. Definition. R squared represents the proportion of the variance in the dependent variable that's predictable from the independent variables in a regression model. It ranges from 0 to 1, where 1 indicates a perfect fit. Standard error of the estimate. It is a measure of the variability or scattering of actual data points around the regression line. It quantifies the typical distance between recognized values and the predicted values by the regression model. Purpose of section 10.3. Understanding relationships. The main goal is to understand how well the observed data fits into a regression model. It helps determine how strongly variables are related to one another. Measuring accuracy. Regression analysis is used to measure the accuracy of predictions or estimations. This topic helps in assessing these estimations' accuracy. Model fit evaluation. This assesses how well the dependent variable fluctuation are explained by the regression model in relation to the independent variables. Importance of statistical measures in agriculture decision making. Predictive accuracy. Accurate predictions of crop yields, weather patterns, disease outbreaks, and other factors are crucial to farmers and agriculture enterprises. Risk assessment. There are hazards associated with agriculture that are specific to the weather, pests, market, volatility, etc. The standard error of the estimate supports risk management techniques by helping to assess the degree of risk associated with forecasts. The importance of statistical measures in agriculture decision making. 2. Optimal resource allocation. In agriculture, decisions are made on the distribution of resources such as labor, fertilizers, and water. Statistical data provides valuable perspectives on allocating resources, maximizing productivity, and reducing expenses. Investment decisions. Agribusinesses and farmers often invest in new equipment, infrastructure, or methods. These choices are supported by statistical metrics which provide evidence-based insights into possible outcomes. Precision agriculture. Data analysis plays a major role in precision farming methods used in modern agriculture. Statistical methods make farming more efficient by assessing the bigger quantities of data that are gathered by sensors, drones, and other technological innovations. Insurance and financial planning. When it comes to handling crop insurance, determining premiums, and evaluating insurance claims, statistical measurements are essential. Using standard error and risk assessment for crop production. Prediction reliability. Model performance or crop production estimates are tested for accuracy using the standard error of the estimate. Risk mitigation strategies. A greater range between expected and actual yields is indicated by larger standard error values, which also imply higher risk. Optimizing risk management. Using this type of measurement, agriculture companies may create plans for risk mitigation, such as insurance planning, diversification, or practice adjustments to handle crop production risks. Example 1. Dataset. Dependent variable is crop yield per acre. Independent variable is rain, fertilizer usage, and temperature. This is the gathered data. As you can see, we have corn yield, rain, fertilizer usage, and temperature. First, what you want to do is calculate the means. The mean for the rainfall is 10.8, the mean for fertilizer usage is 108, the mean for temperature is 76.2, and the mean for corn yield is 170. Crop yield. Predicting crop yields. Step 2. You want to use this formula to calculate the coefficients, and you plug in your values, and those are your first set of answers. Next, step 3, you want to calculate the predicted y-hat. Those are the predicted y-hat values. Step 4, calculate the residuals. That is your formula, and those are the first set of answers for the residuals. Lastly, you want to calculate r squared. That is your formula, and r squared is 0.85. Example 2, calculating standard error of the estimate. First, we want to gather data. This is data gathered on rainfall. Second step is to find the sum. That is your equation. Third step is to determine the number of observations, n, and predictors, k. Assume that the number of observations, n, equals 5, data points, and the number of predictors, k, is equal to 1, rainfall as the predictor. Step 4 is to calculate, and that is the formula and the answer. Example 3, testing the effectiveness of a new agricultural technique. Demonstrate the use of R² in evaluating experimental results. Given the regression derived is predicted yield 55.57 plus 8.3 and the technique effectiveness. This first step is the setup. The second step is to find y for x equals 3. That is your given. The third step is to determine the standard error of the estimate, and that was pulled from earlier. The last step is to use the formula to calculate prediction interval. That's your given. You plug that into the formula, and solving the expression will determine the 95% prediction interval for the crop yield at x equals 3. Decision making, how farmers can use statistics to better crop production. By comprehending prediction models, resources like pesticides, fertilizers, and water may be distributed more effectively depending on projected crop yields. Preparing for potential hazards like inclement weather or market crashes by evaluating the accuracy of forecasts. And using mathematical models to predict helps with crop rotation and optimization for soil health and market demand. It also helps with crop selection and timing.